Okay, hello everyone. My name is Zhang. I'm from CWI Amsterdam. I work in the MongoDB database group. Today I'm going to introduce SciQL to you. It's SQL-based SQL language. SQL-based array query language for processing all your data inside a database system. So this is just a tiny fraction of the antennas of the low-frequency array radio telescope, centered in the north of Netherlands in Europe. One of the main goals of the LOFAR project is to study the behavior of transient sources, for instance, such as those twinkling little stars hanging out there in the dark. They want to build a catalog of those sources over time, with information over time at different frequencies and with different parameters. Briefly, it works as the following. The LOFAR telescope takes pictures of the northern sphere once in a second, for instance. The raw image data is first processed and the sources are detected. For each detected source, we compare it with sources already in the catalog to see if it's a source already detected before or it's a new one. In all cases, we store all useful information about this source in the catalog. This is called the source association process. After this, we can retrieve data from the catalog for further analysis. For instance, we can study the flux change of a source over time. So that's a brief. That's just a nutshell of LOFAR. Next, I'm going to talk about how we can use SciQL to express the data storage and analysis operations for the LOFAR catalog. This is how we model the LOFAR catalog using an array. First, we divide the. Okay, so first we divide the sphere into several areas. Then we have 3 more dimensions to store the time, frequency, and the Full-Stokes parameters. Finally, that side, we store all auxiliary information of a source as cell values, and putting all this together. And the whole LOFAR catalog can be stored in a single array with 6 dimensions and a number of long-dimensional attributes. So with the LOFAR telescope, we can study the similarity of the flux of a source at different frequencies. And this actually boils down to compute the cross-correlation of just the 2 time series. I will skip this, but what you should notice here is that sorry. Can I go back? No. Okay. Okay, so what you should notice here is that to compute a cross correlation, the window size of every iteration is different. So it's extremely difficult to compute operation like cross correlation in SQL. So normally, if we need to compute complex mathematical functions, we need to hook up an external library as a user-defined function. However, using with SciQL, we can now also directly express such complex operations in the language. I hope I can go back, actually. Seems not. Okay. So this piece of SciQL array is everything you need to compute cross correlation between 2 time series. So these 2 statements, they first retrieve the time series data from the catalog, then in this group by statement, the SciQL array tiling feature allows us to dynamically compute different window sizes for every iteration. Okay, so that's just one example. And if you are interested, please come to my demo during the break. And we are interested in your use cases, and we want to know what, if, and how SciQL can help you to analyze your data in a more sufficient and efficient and more convenient way. Thank you.